Well, this is a drawing board. Modern day, it's portable. It has a parallel motion. It's easy to move around. This is A2, and the handle folds out to provide a support so that you can draw at an angle on your desk. There's a similar A1 version, which again is portable, and will fit on your desk quite well. These are recommended. The only caveat is that you must keep the surface clean. It's not a cutting mat. Don't use it for cutting. Paper. In this case I'm using a layout paper. Other papers to use are tracing paper or tracing film. Tracing paper is a little bit more delicate and doesn't last as long as film. Tracing paper was used, tend to be used more for die line copying. Nowadays, when most copying is done through photocopying or Xerox, then an opaque paper is fine to use. The fixing I use, I prefer clips. If you use tape or blue tack, it tends to mark the board. You must, as I said, you must be careful with the board and make sure the board is clean before you put the paper on, because any marks on the board, scratches, any dust underneath the paper will show up through in the drawing and make the drawing look dirty.
Parallel motion, as you can see here, is used for drawing horizontal lines. It's important in technical drawing to be able to draw lines that are parallel to each other, that that have an integrity toward each other, and also are square to each other. So we use, as you can see here, the set square for vertical lines and the parallel motion for horizontal lines. If you don't have a board with a parallel motion, then you can use what's called a T-square, which you see here. And the T-square does the same job as the parallel motion, but is independent from the board. What's important is to be able to keep the side of the T-square up against the edge of the board, or you can lose having parallel lines to each other, and it can all get a bit wobbly. But as you see here, I'm using a T-square and a set square, so that I can draw both horizontal parallel lines, and in this case, because it's a 45 degree square, I can draw lines at 45 degrees to both the horizontal and the vertical in this case. The compass. The compass is used to draw curves. It has a point at one end and a pencil lead at the other end, and it can be adjusted with a wheel in the middle. Here you can see describing a circle around the point, and that point is fixed on the line. What I'm going to do now is show you how the compass can be used to create a line that's perpendicular to the original line. What I've done is used the circle that I've described, and where the circle goes through the line, I then use the compass to create a point, and where the two arcs bisect, that point will be perpendicular to the original point on the line. You can see how I've drawn a line there to create that. And in the same way, you can then bisect the resulting angle. So if we've gone from a straight line to a 90-degree angle between the horizontal line and the vertical line, and then where they're bisected with the circle, you can then create 2 further points using the compass to create a bisected angle which will be 45 to the horizontal line, and of course 45 to the vertical line as well. And again we can then bisect that angle, so we're bisecting the 45-degree angle using the same method, and we will end up with, I suppose it's 22.5 degrees between the two. So we've created a 90-degree, a 45-degree, and a 22.5 degree, using the compass to bisect the original angles. If we, with the compass, recreate the radius of the original circle, and we take a point on the circle and then scribe a line across the circumference of the circle, that will make an angle from the center to the horizontal of 60 degrees, and in this way it's possible to mark out as you go around the circle with the compass. Using the radius, you will end up with a hexagon that it will break the circumference of the circle equally up into six units. And going from a point on the top of the circle, coming back again, you can see how what it's doing is breaking the circle up into 30-degree units. So for 60 and 30 degrees, it's possible to use the compass on a circle by taking a point from the circle and then bisecting the circle.